Hey everyone, welcome back to my Calculus 1 series. In today's lesson, we'll be talking about derivatives of polynomials and exponential functions, as well as a few rules to help simplify derivatives. So firstly, let's get started with the three simplification rules that I have at the moment. Like in previous videos, I'm going to do where I group the simplification rules together, and then I group the actual calculation rules or computing rules together as well. So firstly, let's start off with the constant multiple rule. The constant multiple rule basically says that if we were to take the derivative of a function, f of x, that was multiplied by a constant factor c right here, this derivative can be simplified by bringing the c out in front of the derivative. So it would just be c d over dx, meaning the derivative of f of x. So what this rule is saying is that we can evaluate this derivative just by itself and later multiply by this constant factor of c. The next rule that we're going to cover is the sum rule, and it is exactly what it sounds like. If we have the derivative of a function, f of x plus g of x, if we were to take the derivative of this whole function right here, this can be simplified by just taking the derivative of f of x first and then adding the derivative of g of x after. So there you go. We're first going to take the derivative of f of x and then add the derivative of g of x. Lastly, for this video, we're going to have the difference rule. And again, it is what it sounds like. So if we have the derivative of the subtraction of two functions, so f of x minus g of x, like the sum rule, we can simplify this by taking the derivative first of f of x and subtracting by the derivative of g of x. And again, here's the derivative of f of x, and then we subtract the derivative of g of x. So now on to the constant multiple rule, or like these are now going to be the simplification ones. So let's say we have a constant multiple as our function. So if we have the function y equals c, where c is a constant, and we're asked to find the derivative of y with respect to x, x being the variable, this right here is going to equal to just 0. I should probably write this a little bit differently, so we should be writing that d over dx, and then let's call this, actually I'll make it here, let's call this f of x. So d over dx of f of x is going to equal to 0. So the derivative of a constant, no matter what it is always going to be equal to 0. So for a polynomial function, f of x is going to equal to x to the n. And again, I'm not going to put a constant in front of here because we do have the constant multiple rule, which will deal with it and essentially just simplify it back to this polynomial. So here we have it, f of x is equal to x to the power of n. And if we were to if we're being told to take the derivative of f of x, we can do that by dropping this power out to the front. So we would write n times x, and then we would subtract 1 from the power. So this right here is a very common formula for finding the derivative of polynomial functions, and all you do is you are going to drop that power and then subtract 1 from it. And the last one we're going to go over in today's video is exponential functions. So again, if we're given f of x is equal to b to the x, where b is a base, and then we are told to find the derivative of f of x, of this function, this would be equal to ln b times b to the x. So the b to the x would stay the same, and all we would do is we would take the ln of the base. And just a little build off of this, if we have the special function e to the x, it's going to follow this rule, except it's going to look a little different, and I just don't want it to stump you later on. So if we have the derivative of this function, e to the x, it's going to equal to ln e times e to the x. But we know that ln e is equal to 1, so it's just equal to e to the x. So this is kind of cool. This is maybe, I'm not 100% sure if this is the only function that does this, but essentially the derivative of e to the x is just e to the x itself. So the derivative is the function itself, which is pretty neat. So here I have a few examples to basically solidify what we have learned. So for example number 1, we're going to be dealing with a function that is just a constant. So f of x equals 2. And we know that if we're asked to find the derivative of f of x, this is just going to equal to 0 because it is a constant. Likewise, for this problem right here, d over dx of f of x is also going to equal to 0 because, again, this is a constant. And lastly, as you can tell, this right here is also going to equal to 0 because even though it is a big number, the rate of change is 0. Like, that's what the derivative is. And if we have this constant function just sitting up at y equals 1 million, the rate of change is 0. Like, it doesn't change as the x changes at all. Now moving on to a bit more interesting functions. If we are asked to take the derivative of this, this is how we would go about it. So we have this function right here, and we want to take the derivative. So we are going to use the sum rule and break this up. So we're going to say d over dx of 4x squared plus, oops, I should close this off, plus d over dx of 3 to the x, or 3x I should say. And I'm actually just going to move this down right here so that we have a bit more space. So now we have these two derivatives to deal with by themselves, and again we can simplify this even further because it is a constant multiple. So let's bring the constant multiple out of the derivative. So we could say 4 times d over dx of x squared plus 3 d over dx of just x. And now finally we have a bare bone function that we know how to take the derivative of. So this is going to be 4 times the derivative of x squared. Well, we are going to drop the power, right? And then we are going to subtract 1. So this is going to be x to the 1 plus 3 times the derivative of just x, right? So if we think about it, it's x to the 1. We're going to drop the 1, keep the x, and then the power is going to get subtracted by 1, which is going to be 0 now. So now if we simplify this, this will be 8x, and then this will be plus 3. So as we can see, the derivative of just x will be 1 because we are going to drop the power, and then x will be to the power of 0, and we know that anything to the power of 0 is just 1 itself. So we just get this value of 3 left. Moving on to this question, we are going to take the derivative of this function, right? And it's going to equal, like we did in the other question, we're going to take the derivative firstly. So there, plus 4. And now, like we did in the other question, we're going to break this problem down using the sum rule. So we're going to take the derivative of the first function, which is this one, and we're going to add on the derivative of the second function, which is just a 4. Now, this second piece right here is the derivative of a constant. So we know that already. However, this one we can apply further steps, and basically we know that this is a constant multiple of a function, so we can move that constant multiple out of the derivative function and just keep it like this. And this will stay the same because nothing will change. Now that we have the bare bone function, we can finally find the derivative. So it will be 4 times, and then just because it's a negative, the differentiation rules stay the same. We're going to drop the power, and then we're going to keep the variable, and we are going to subtract 1 from the power. So 3 minus 1 will give us minus 4 now. And then we're going to add on the derivative of 4, and that, as we know, is 0. So here, the final answer will be minus 12x to the minus 4. Now on to this derivative right here. So we're going to take the derivative of this function. And like we did with all the other questions, first we start off by applying the operator. And again, we can see that this is a combination of functions. So what we're going to do is break this up. We're going to take the derivative of the first one, which is 2x cubed, subtract away the derivative of the second one, which is 3x squared, add the derivative of the third one. Oops, this should be a minus 1, and then it should close, and then we're going to add the derivative of 10. So again, we're going to apply the constant multiple rule and simplify these derivatives even further. And again, there is nothing to do for this last one right here, because it is just a constant function. It's just y equals 10. So again, now that we've got bare bone functions, we can simplify them, or I should say solve for the derivative, and it will go like this. So we'll keep the 2 here, and for x cubed, we know we'll drop the power and subtract 1 from the power. Here we'll keep minus 3, drop the power, and subtract 1 from there. Then we go on to 8, d over dx of x to the power of minus 1. So we're going to get minus 1 times x, and minus 1 will give us minus 2. And lastly, we know that the derivative of a constant will be 0. So once we simplify this, we're going to get 6x squared minus 6x to the power of 1. So we don't need to write anything there. And then we'll get minus 8x to the minus 2. So moving on to these last few examples, here we have this function, and we're going to take the derivative of it. So it's going to equal to the derivative operator of 2 times 2 to the x. And we can see that this is a constant multiple. So first, let's bring it out of the derivative operator. And now we know how to take the derivative of an exponential function. It's simply the log of the base times the function itself. So we're going to end up with 2 times the ln of 2 times 2 to the power of x. So moving on to the next problem, let's find the derivative of this function. So let's apply the derivative operator. And one thing to notice is this negative sign. We can kind of simplify this even further by doing something like this. And again, this is a constant multiple right here, so let's bring that out to the front. And we know how to find the derivative of that. It's just ln 3 times 3 to the x. And there you go. There is our derivative. And lastly, we have this one problem. So we're going to find the derivative of this function. So again, we're going to apply the derivative operator. And now we can take out this constant factor right here. And again, we know how to solve this. It's just going to be the ln of 4 times 4 to the power of x, and that is our derivative. That's it for this short lesson on how to evaluate certain derivatives, very simple ones, and also a few rules to kind of simplify big expressions. Hopefully you enjoyed this video. If it helped you at all, please like and comment as to what it helped you in. If you're new to the channel, please like, comment, and subscribe. And yeah, I will catch you guys in another video.